All right, guys, this week we're talking about torque, and torque is the amount of force that can move an object around its axis of rotation. All right, so there's two parts we need to think about this. We need to think about the axis of rotation and then the moment arm. Okay, so the moment arm length is going to impact how much torque is required to move. The shorter the moment arm, the easier it's going to be, the less force required to move that. Whereas the further away, the longer the moment arm, the opposite is true. So that's what we're going to be looking at in this lab for week 4. The way that we are doing that is with sit-ups, okay? So you guys are going to get into your groups, and this will be in the turf room, but we will still meet in the regular lab where we always do. There's going to be mats laid out and medicine balls. The way that we are going to do this is you will do one trial where you do as many sit-ups as you can in 60 seconds with the ball at your chest, okay? And then you do the same thing for 60 seconds with the ball up overhead. You guys will be taking turns doing this so that you get enough rest so that that doesn't impact the data. But essentially, we were just comparing how many reps of sit-ups you can complete in 1 minute at the two different positions. And what we will likely see is that when the ball is overhead and we have increased that moment arm, we have to use more torque to get that sit-up completed. We have to work harder, and we can't do as many reps in that same amount of time, okay? So for the first trial, you're going to be doing them, like I said, with the ball at your chest, just like the pictures show. And then in the video, it also shows the two positions, okay? So the first one with at the chest, and then your partner will go. That gives you enough rest time so that when you come back, you're not impacted by the first set. This time you'll keep the ball overhead the whole time. So you're keeping it up overhead the entire time you do that 1 minute of sit-ups. And all you're doing as the partner is you're tracking how many sit-ups they get. You just write that down for overhead, write that down for at the chest, and then you're good. That's pretty much what we're doing in the lab. All right, for the lab report, you guys are going to have to make a table, and that will be something that we make in class, and then you guys will just replicate that into your report. And you will also be making a bar graph. All right, but with the table, you're going to do a average and standard deviation for both at the chest and overhead, just like it has in the example. And then you're also going to be performing a t-test. So there's a video on Blackboard for how to run a t-test, and there's also written instructions right here that you guys can check out. It walks you through exactly how to do it. And we do a t-test to determine our p-value. Our p-value tells us how confident we are that these two data points are correlated. So if you look at the figure 3, class average sit-ups with medicine ball overhead versus held at the chest, the data represents mean plus or minus standard deviation, significantly different from overhead. P is less than 0.05. So this is critical for you guys' report and really to note in general. A p-value less than 0.05 means that the data is statistically significant, the differences. So that means that we are confident this is not up to coincidence and that they actually had an impact on each other. All right. So for the lab report, you'll have your table. The t-test is going to give you your p-value. And then when you have that p-value, if it is less than 0.05, then we will put an asterisk on the bar graph, okay? You put it on the bar graph just like it is in the example. You can do this in Excel, but you also can just put an asterisk in over top of your graph once you copy and paste it into your report itself, okay? But you will want the error bars and the asterisks in there. When you look at the discussion questions, after you've got all of that complete, number 1, look at your results section and explain the main finding based on your p-value. Was there a significant difference? So exactly what I just talked about is that p-value less than 0.05. Explain the main finding. Was one of these trials harder than the other? Did one trial show more reps on average than the other? You guys get the idea. And then based on that p-value, where it is surrounding 0.05, greater than or less than, is that significantly different? Number 2, explain why this makes sense or doesn't make sense based on class discussion and lecture notes. So use what you guys talk about in lecture and class discussion on torque, the moment arm, axis of rotation, where everything is. Does this make sense? All right. Does it make sense if the overhead is more difficult when that moment arm is longer, right? Think about that. And then question 3, give a practical example of how this would come in useful when designing a strength training routine. So get kind of creative with this. Think about what you know about exercise programs and think about the body's biomechanics. You can think about if you're holding a dumbbell in your hand, maybe the shoulder is your axis of rotation on like a lateral raise, and then your hand is the end of the moment arm, okay? If I shorten the moment arm at the elbow, how would that change things? Or vice versa, if I'm pushing from the elbow and then now I put it in my hand, how does that change things? Okay, so that's what we want you guys to be thinking about and going along that route for this answer. You cannot use these sit-ups with the medicine ball for your example because we did that in lab. Okay, make sure you answer the entire question. So give the practical example and also how can you increase or decrease the difficulty of an exercise with the knowledge of torque. So make sure you answer both those, give an example, and then essentially explain why that would make it more or less difficult. Yep, pretty easy lab this week.